let's have a look at using these linear functions, these straight line graphs. So to be able to use that, we need to find the equation of the line. Once we have the equation of the line, we can use it to solve questions either where we extrapolate and go past what we can see on a graph, or interpolate and solve questions within the graph but with more accuracy. So to find the equation of the line, I love that this technique is used in the higher level of maths when I teach Year 12 methods. To find the equation of a line when we're doing calculus, you need a point and a slope. And it's the same here for the middle level of maths, for all levels of maths. Equation of a line, you need a point and a slope or gradient. The easiest point to have is the y-intercept. And the reason for that is in this particular format, you can just substitute that number straight in here for the plus c. And also the x value at the y-intercept is 0. And that often makes things much easier to work with. So in this example here, the graph is the height in millimeters of a candle X hours after it was lit. So having a look at our axes, on the horizontal, the x-axis, we're in hours that we're measuring that by, and our vertical axis, the y, is millimeters. So you think about how tall this candle is. Well, how tall is it to start with? Looking at the scale, this is where it starts before the burning has started, and that is 90 millimeters tall, which is 9 centimeters. Thinking about why that line is going downhill, because the candle is burning. So what's happening to the height of the candle as it burns? It's decreasing. So we're going to start creating the equation connecting the x and the y variables. So we need to start with the point, the y-intercept. And what is that? That is 90. So we've got that written here. Sometimes it's handy to write that as a coordinate where you put 0 in for the x coordinate so that you're remembering that they're a pair of values. And so that's our c value. So it's actually plus 90, as you can see here. So that's going to come in handy soon. So that's the y-intercept. Now what about the slope? So to work out the value of the slope or the gradient, those words are interchangeable. It's the rise over the run, or the y step over the x step. So when you're given a graph, how do you find that? Look along the line and look where it goes through the grid squares, through any corners. It did at the y-intercept there, but let's see if we can find some others as well. So you follow the line along until it goes through a blue corner. Here's one. Where's the next one? Down here. So we need to work out what the coordinates are of those 2 points, and then we're going to use them in our formula. You can work it out with the rise over run. Now that's an interesting phrase here because it's not rising up, it's actually rising down. So it's this vertical distance over the horizontal distance is our slope formula. So it's not 2 over 5, because you'd have to consider the scale. You're welcome to just do that where you work out the scale and bear that in mind, but I just want to show you the technique that works all the time using the y2 take y1 over x2 take x1. So these are our points, noticing how they line up. X coordinate first, so it's 5, 70, and then over here, this dot here lines up with 10, 50. So let's use that. Here's our formula, the y2 take y1 over x2 take x1. Label each of those coordinates. You can label it on the graph there. One point is point 1 and the other point is point 2. Point 2 is further along the graph. So that point is the 10, 50. 10 is the x position, so that's in x2, and the 50 is y2. Therefore, the coordinates over here are x and y, and they are the first point, so that's our x1 and y1. Then we substitute those values in to this formula here. y2 is what number? 50. Subtract the y1 value, 70, over x2, which is 10, subtract x1, which is 5. Continuing to work that out, on our numerator, 50 take 70 is negative 20, and our denominator, 10 take 5, gives us 5, and that simplifies down to negative 4. We're expecting a negative number because it's going downhill. So that's going to be our slope value, our m value. So there's our m and there is our c. Let's substitute them in. Here's our formula. Let's see where we do that. The m value there, we put in the negative 4 in place of an m, and then the 90, we substitute the 90 in instead of the plus c, so we're doing plus 90, and there is our equation of the line. But sometimes it's more meaningful to write that with variables that are relevant to the particular question. So in this case, it was height, so the letter y doesn't necessarily imply height, but h for height does. There's our h there, and t for time. So we're changing the x to a t. It's quite common that we do a capital letter on the left there for the y value and then a lowercase letter for the x value, or within the right hand side of the equation. We then need to use that information to solve some questions. So what's the height of the candle after 12 hours? Have we got the h or the t value? This number here, this 12, is a time value. So let's substitute that in. Here's our formula. H is equal to -4t plus 90. We've been given a t value of 12. Let's substitute that in. Another way you could write this is -4 multiplied by 12 plus 90. That's perfectly acceptable as well, or the brackets are fine. Working that out, we get -48 when you work -4 times 12 out. Adding on 90, we're left with 42. Make sure you put your units in millimeters. So after 12 hours, we're 42 millimeters high for the candle. But how long will it take for the candle to burn out? Now this question doesn't have a number in it. Is it the H or the T we're solving for? So you have to think about, what does burn out mean? It means that the height of the candle has gone all the way to the bottom and we're left with nothing. So the height is 0. So that's the number we're going to substitute in. So start with your equation and substitute in the value. So where we see the H, we're going to put in a 0, which is on the left-hand side of the equation. I'm going to do this in two ways. Now we need to rearrange and solve for t. So on this step here, you can see that we have essentially added 4t to both sides of the equation, which means it's disappeared from the left and it's it's disappeared from the right and it's moved to the left. Or another way of thinking about it is when it moves over the equals, it changes sign. It becomes a plus 4t here. Now we need to divide by 4 to solve for t. So we have 90 divided by 4, and we're left with t is equal to 22.5 hours to burn out. I'm just going to show you another way to rearrange this. It might depend on how your teachers taught you or what you're used to from previous year levels. I like to put the thing that we're solving for on the left-hand side. So I automatically just rearrange that equation. So I pick each bit up and just swap them. No signs need to change. And now my brain says -4t, add 90. The last thing I said was add 90, so that's the thing I'm going to move first. It's a positive on the left-hand side, so it needs to become a negative on the right-hand side. And now I can divide through by -4, and you'll notice that we'll still get the same answer. So -90 divided by -4, it's going to leave me with a positive answer, and that comes out to be 22.5 hours. So you can see we can still get the same answer depending on how you've been taught how to rearrange. Just a reminder about the use of technology. You would now be encouraged to put this into your graphics calculator into the graph mode, because then we can use GSolve to work out the Y-calc and the X-calc that we practiced in that last video to check these answers that you're doing. In case you're not very good with your algebra and rearranging, use your graphics calculator to check that answer for you. Or if it's only a 1-mark question, you might just be able to use your calculator to get the value. There are the questions to do now. Give this a thumbs up if you liked it. Thank you.